Hello. So to answer your question, an ontology sort of necessarily includes a taxonomy, and that's the tree structure of the relationships. But other ontologies also include different kinds of relationships between classes, like inheres in or something is part of something else. And yes, this is an application ontology, so it only has that is a structure on there. But yeah. So my name is Luke. I'm from the University of Birmingham. And so we've just heard from Tassos sort of, oh, this is helpful, the kinds of things that ontologies are, in that they describe the kinds of things that exist within a particular domain. And now we're going to move from that to talking about the eNanoMapper Ontology and some various points about it. So first we'll talk about, thank you. First the introduction, which is now, and then we'll talk about sort of the design goals of the eNanoMapper Ontology, and then a brief sort of overview of sort of how it's designed, what this enables, what it's used for, and then as a start of our sort of journey throughout this workshop, we're talking about what it is used for. We'll give a brief sort of overview of how to access and browse it, which is possible in various ways. So what eNanoMapper attempts to achieve, as we talked about previously, each ontology tries to cover a particular sort of domain of interest. And our domain of interest is nanosafety, or facilitating the description of toxicological descriptions within nanomaterials. And we also want to sort of describe this domain in a sensible way in relationship to other well-characterized domains in science, so descriptions of chemicals or information and that kind of thing. And then we want to move on from this description of the domain to start to annotate data, annotate experimental results, and then we want to reap the rewards of all these sort of good things this enables, which I'll sort of overview in a bit, and also Tassos talked a little bit previously. So this kind of ontology, which is often a taxonomy, and sort of is for the purpose of describing a particular domain rather than sort of an entire realm of basic science, like something that gene ontology does. It's called an application ontology, and it often pulls in parts of other ontologies that are relevant to it, as well as defining things that are particular to its domain as well. Another example, which is quite big, is the EFO, the experimental factors ontology, developed by EBI, which is quite widely used within their organisation and outside of it to annotate experimental results, and is then in turn used to manage them and retrieve them and experiment upon further. So the design of this in turn, if we want to talk about something working very well within the sort of wider ecosystem it exists in, if we're using common definitions of things, that fits in very nicely. We're not sort of repeating definitions, we're not making up our own definitions, except where they diverge or make more specific things that already exist and are already defined. So we have lots of ontologies out there, like CABI, chemical entities of biological interest, I think, the information ontology, and probably most relevant, the nanomaterials ontology. So all of the stuff that we're sort of interested in eNanoMapper has already been defined. And so we can see that it sort of exists at the intersection of many domains, and for the purpose of developing this ontology, a tool called Slimmer was developed, and it sort of, in a very nice way, picks out parts of other ontologies, be they subtrees or particular classes, and pulls them into the structure of this ontology during the build process. And then within this sort of wider structure, we can add our own definitions where they are relevant. And so what's produced is, and this is not my graphic, I give a credit for it later, and I think it's slightly out of date as well, but you can sort of see how at the top we're moving from upper level ontologies. That's the basic formal ontology, which describes in a very general sense the kinds of things that exist in the universe. So a distinction between sort of processes and qualities and permanent events or individual sort of one-time events. And then we're moving down into sort of different categories of things that we're interested in. So you can see information in the middle, or bioavailability and toxicity on the left. And then we're moving to where you see ENM, that's stuff that we've determined and described ourselves. So we're talking about carcinogenicity, oral toxicity, and that stuff that has a particular meaning that's not sort of well covered in other ontology. And so, I mean, that's probably a bit confusing, but you can see how we're moving from a general to a specific set of definitions from other ontologies which are particularly designed to cover that domain. And so what this enables is, first of all, we have this artifact that sort of nicely organizes and categorizes and describes the things within this domain, and we can use any set of tools to sort of interact with that and search for data, search for definitions. And then what we're going to be doing today is annotating experimental results with these ontology terms. So we have entities in our instantial data, in our experimental data, and we're going to be linking it to the ontology and saying, this is the kind of thing that we're talking about here. And what this enables in turn is all kinds of wonderful things. So firstly is sort of semantic data lookup. Instead of working with our database of experimental results in the sense of sort of searching by a text label or something like that, we can look things up based on concepts, be they more specific or more general. And this can be used for kinds of things like searching PubMed or other biological databases that are sort of disparate but are also linked to ontology terms that pull things together in a very nice and interoperable way. And then from the sort of data science or machine learning aspect, we can use ontology-enabled techniques to learn new things from this data. And one sort of area where this has been quite successful potentially is in the gene ontology, where sort of functional annotations using the gene ontology for genes has been used to predict protein interactions and gene orthology and that kind of thing. And so we'll talk about sort of very quickly how to browse the ontology. So I've only covered sort of a very quick sort of overview using BioPortal, but I would recommend opening this tutorial, and also next within the sort of NanoCommons portal there's a tool to be searching the ontology, which I think we'll actually be using today. But the principle is all the same. So on the web there are many tools, and talk about BioPortal and Adderall. BioPortal is good for these kinds of things because it's very quick relatively, and tends to load nicely. And then there's Adderall, which sort of tries to bring in the logical inferences and this kind of thing on the web. And then on the desktop there's mainly sort of one tool called Protege, which is largely used for creating and editing ontologies. So the tutorial link is also on the other pages as well. This is very sort of, you can't read it, but fine. So this is the eNanoMapper summary page on BioPortal, and you have information like the visitors. You can download it on the bottom left. You have statistics on the number of classes, who developed the ontology, and this kind of thing. But if we want to start to sort of explore the tree of this ontology, we can click on the Classes tab, and on the left we get this sort of hierarchical view that we discussed earlier. And you can click around it and you can expand subtrees and click on items, and this is basically true of every ontology explorer that exists, because I mean it's that kind of data structure. And so on BioPortal you have the jump to box, which is also a label search. And one thing as annotators, and this was discussed before, but it's important to remember that it's a subsumptive relationship between each thing, which is to say that each thing is an instance of its parent. And that seems kind of obvious, but it can get kind of confusing if you start to think of things as being categorized in different ways. So you can see that carcinogenicity is a kind of toxicity, it's a kind of logical endpoint, is a kind of endpoint, all the way up to entity. And so when you're clicking on something, on the left, up on the right comes up all the details about that particular class. That's not carcinogenicity, that's citation. I picked this one because it has quite a lot of nice information there. So you've got usually a label and a description, depending on where the class comes from in terms of which ontology it comes from. You sometimes have other information, so here you have example of usage, which is quite nice. And all of this information is designed to help you figure out what kind of entity this is talking about. And the important thing for using it in turn for annotation is the ID, which you can see is like a URI, a web link. And this is the sort of ID of the class which you will use for annotation. We use this ID instead of a label because obviously in different domains of interest you might have different definitions of the same thing. So we're talking about a very specific thing and we use the ID to refer to it. I think that's about it. So yeah, Janet Hastings for the design graphic. And next we'll talk about actually using the ontologies for annotation. So thank you and feel free to ask any questions.